Studios.
Calypso gets it. This video is dedicated to Bob from Globebusters. Recently he asked a couple of questions in a chat and they were sent to me because it's me. Bob says, I have a question and I hope all of you can bring all of your collective brain power to answer this most difficult question. It would sure help me a lot. No problem, Bob, that's why we're here. This is a question specifically to those who do not believe that a downward acceleration, also known as gravity, exists, and that would be me, and instead believe that it's all about relative density equilibrium. Do you know what, Bob? At least you've dropped density buoyancy. If I climb a ladder to 100 feet above the ground, I think it would be safe to say that the air or the atmosphere above me is less dense than where I am on the ladder and the air. Or, atmosphere below me is more dense than where I am on the ladder. Why, if I step off the ladder, will I fall down into the more dense medium instead of up into the less dense medium? If all is density equilibrium mediation, then shouldn't I fall up? Since there are those who claim that no downward acceleration, also known as gravity, exists, then we seem to have a small conundrum here. Calypso. Bob, I think it's because you're more dense than the Earth still. Well done, Calypso. Calypso gets it. Globebusters back to Calypso. But I am more dense than the air above me. Why am I not falling up? Bob, mate, we've been saying this for years and you've been fighting it for years, and today, hopefully, you're going to get your answer. So, here we have the density tower. Okay, so Bob asks, why am I not falling up? I need something so that I can move. So here we have Bob. It's a little bit more, a little bit less. It depends on his particular body style. A muscly guy is going to be more dense than the medium of water. A not muscly guy is going to be less dense. So we know that Bob is going to be water density, and we know that Bob's less dense than water because he's got less muscle. He's going to sit in the middle here. Now, if Bob was to get a ladder his density would stay the same, but his density relative to the medium's getting less dense around him. If he jumps off the ladder, he's going to gently go back down to where he was, because that's where he came from, because he's in equilibrium. He's the density of the water. However, if we tie a rope to his legs and pull him downwards towards the more dense medium, and then let go of the rope, he wouldn't fall down then, would he? He'd fall up. So when Bob asks, why is it that he is not falling up? Because he's not a helium balloon. He's far more dense than the medium that he's in. Yeah, he's going to be seeking his equilibrium, because in air, he's miles away from his equilibrium point, isn't he? Because he's far more dense than it. But when he's in water, he's a lot closer to it. But here's the thing, Bob. We all know that you don't like doing what you're told. So I'm going to respectfully make you move without you wanting to move. We know that your density is equal to the water, give or take a little bit. If I add salt to that water, I can make Bob move. And he doesn't want to move, but I can make him move. So by changing the density of the water around Bob, I can make Bob move. Bob's going to move up in his language, but in my language it's seeking his equilibrium because I've just made it more dense around him. So that pushes Bob up. Pressure. It pushes against the walls of the container and against the liquids above and below it, and Bob can't sustain it. He can't remain in this. He's out of, when I add the salt, he's out of equilibrium and he's now in disequilibrium. And as the density increases around him, he's going to now relocate because pressure pushes him. I'm increasing the pressure around him by increasing the density. So the independent variable is changing the density of the medium. The effect is that there is an acceleration and it's caused by pressure.
Force could be the pressure as well, right? It could be, there's all kinds of forces.
It could be.
We're talking about, yeah.
It could be. I don't know. That's the whole thing. But
everybody that understands relative density disequilibrium understands this. Bob, if you don't understand it and you still won't talk to me about it and you still don't get this video, go back to Calypso, because Calypso gets it and he understands it and he knows that the cause was me causing adding the mass, because that's what happened, Bob. You became the egg.
Here's a fun question for Riley. What's denser, an egg or water? If all that matters is relative density, then the egg should sink.
Funny you should ask that question. Today's video we'll be doing a little bit of science and we will be observing how we can manipulate the medium by changing the density and create a force. Newton said where there is an acceleration, a force must be present. Today's video is all about science. Apply this technology and I could perform a practical scientific experiment where I could measure the density of a medium, in this case water, and I can make this egg move all by itself with just a little bit of salt. I can observe my phenomena to be that some objects appear to float, some objects appear to sink, some objects will suspend in different mediums. My hypothesis is if I change the medium's density, the egg will move. Newton said if an object moves, a force is present. My null hypothesis is that if I change the density of the medium, the egg will not move. I will activate one of the hypotheses. My independent variable, my presumed cause that I must manipulate in an experiment, is the density of the medium. My dependent variable is the movement of the egg. I'll also try and keep everything else constant. The volumes of water, not will change, just the density of the medium. Let's see how I'm going to do this. Because what we're trying to establish is, if the medium is different, does it make a displacement? Does it force a displacement? If it forces a displacement, according to Newton, there is force. This is just normal table salt. from your favourite supermarket. We can tell that the density of the egg is equal to the part in the glass where the liquid is. What I'm now going to try and prove is that if I change the density of the medium, I will cause the effect by adding salt. So if I can change it, because I'm the experimenter and I'm manipulating my presumed cause, my independent variable is the medium, that egg moves, I've caused it. We know the parts per million is about 300. All we need to do is pour some of this in. Hey, what do you know? The eggs immediately moved. Didn't have to wait for that, did we? So, what's the explanation? Well, I'm going to measure this now. This isn't going to be much more above 300. However, if it reads anything above 300, then that'll do for me. How do I reset? There we go. So the density is reading around about 309, 308, 309. If you can have a look at that on the camera if you want to zoom in. But I've just made the egg move. So what's the cause? Well, scientific method states that the independent variable is the presumed cause, and I presumed that changing the density of the liquid with salt would cause a displacement. Newton's first law of motion states that every object will remain at rest unless acted upon by a force, and I've obviously created a force. The density of the medium has displaced the egg. The egg moved. That's an accelerating mass. So therefore, Newton states that there is a force. I caused it with this. So in scientific method, the cause of the displacement is this. I've caused it. I've manipulated it, I added the salt, it caused something. I did it, I'm within scientific method. If you assert that gravity in any way caused something in this experiment, that means you are adding a secondary cause. Adding by inference. If you add a secondary cause by inference, you fall outside of scientific method because you can't infer an extra cause when you've already got one that you've manipulated. You can't infer a secondary cause and remain within scientific method. If you wish to move outside of scientific method, sure, be my guest. Infer that gravity caused in any way whatsoever the effect that we just witnessed, which was the egg moving. But you do so outside of scientific method. And we know by definition, if you are not complying with scientific method, you are practicing pseudoscience. I am staying within scientific method, and I am using my cause and my effect relationship, and I am demonstrating it with using this. I've changed the density of the medium, and the egg has displaced. Within scientific method, the cause is that and only that. You cannot infer extra causes. That takes you outside of scientific method.
From the University of British Columbia, Richard Johns writes, "Before we can discuss inference to the best explanation, we must be clear on what an explanation is. That involves the notion of causation and also of inference. There is an important difference between physical causation and inference. Causation is a physical process that happens in the real world, whereas inference is a mental process. There is a big difference between saying the physical event, the egg physically moves, or changing the density of the medium produced the egg moving, and knowing a gravitational force exists that I can infer that caused the movement. There is a big difference between the two. The nature of the subject, light, permits no other treatment. So it's only where you do not have any other treatment can you infer cause. But thankfully we do. We have scientific method."
So, in anticipation of any reaction to this experiment in the video underneath or the comments underneath, if you assert that there is gravity acting on this in any way whatsoever, you are outside of scientific method and engaged in practicing pseudoscience. Unless you can show me a citation within scientific method that allows you to disregard the cause, the salt, the medium change, and then substitute an alternative one instead, or including, adding to, then you are outside of scientific method. You are practicing pseudoscience. Just by way of footnote, it's interesting to think that the mass of the Earth is below this table. The huge Earth ball that we're supposed to live on. And that is pulling that egg down, isn't it? Apparently. Yet when I added an extra bit of mass to this, the mass below the egg is increased. But for some reason the egg went up. If mass really attracts mass, why didn't the egg go down? It's a rhetorical question. I don't want any answer. Just merely an observation. But if you're going to infer that gravity in any way whatsoever did something in this test, unfortunately you are working outside of scientific method. You're practicing pseudoscience. And nobody on the ball side would want to engage in pseudoscience, would you? The cause of the movement of the egg was changing the medium's density. I caused it by doing that. The effect was it increased a little bit of pressure at the bottom, which displaced the egg. It moved. Newton said there was a force. So I've caused it. I did it with the salt. Gravity didn't do it. It wasn't the independent variable, was it? Can you science, bro?
From the University of North Carolina. In an experiment, the independent variable is the variable that is varied or manipulated by the researcher, and the dependent variable is the response that is measured. An independent variable is the presumed cause, and the dependent variable is the presumed effect. In experiments, the independent variable is the variable that is controlled and manipulated by the experimenter, whereas the dependent variable is not manipulated. Instead, the dependent variable is observed or measured for variation as a presumed result of the variation in the independent variable.
A few days ago, I released a couple of videos aimed at Bob Nodell from Globebusters, where I challenged him to a conversation, and I know that he won't have it, and I predicted it correctly in the video that he would not have the conversation. The reason is because Bob will not accept current science and scientific method, because when it applies against him, he ignores it because he wants to pontificate around pseudoscience as a flat earth pseudoscientist, in the same way that Neil deGrasse Tyson does on the Blurther side. That makes him as bad as the Blurther side of pseudoscience, and he just doesn't like it, he doesn't accept it, but he wants to support it anyway. He wants to push that anyway, because Bob wants to be Neil deGrasse. Anyway, it's been 18 months since I did my test with the egg, and it's stood the test of time. There is not a single baller that can challenge any part of this because they just don't like it. I demonstrated that if I manipulated the density of the medium, it caused an acceleration. The egg moved. Now, regardless of how you interpret it, the fact is that I did something and it caused something, right? And you can argue about exactly what it did and how it did it as much as you want. It doesn't matter. The point is that I caused it and it wasn't anything else causing it within scientific method. If you infer that gravity caused it, then we need a definition, and we all know that gravity is not a force, so it can't be gravity doing it, but you can't even infer causation. You've got to accept that the thing that I manipulated did cause something. Now, I've only come across this today, but this is a fantastic video to demonstrate what actually happened. I do not have the skills to create these simulations, but I found this guy from somebody that was claiming to debunk me. And he didn't realise, because he doesn't realise what's going on here. But now I'm going to show it, because this guy demonstrates what happened with the egg test. Don't listen too much to this guy, because he thinks gas pressure. He thinks gas molecules follow curved trajectories because they're influenced by a general bias down, a bit like Bob does. But he thinks gas pressure does it too. He also thinks that the collisions with the walls of the container are subject to a net reduction in momentum. He doesn't realise that they're elastic, and there is no net loss of velocity with the collisions between the walls of the container. And he also thinks that gas pressure can exist without a container. He thinks that even though he demonstrates it inside a container like Hillbilly Blue Balls when he did gas pressure without a container, this guy also thinks that you can have gas pressure without a container, even though he uses a container to demonstrate it. But anyway, this guy is probably the best visualization that I've come across to demonstrate what actually happens with the egg. I did manipulate the density of the medium. I think most people accept that by putting in the mass, they accept that the density of the medium did increase. But then the egg moved. So most people don't like arguing that, or don't like accepting that mass caused something, because by increasing the density of the medium, current physics does not say that mass can cause anything. But if I change the mass of the volume but keep the volume the same, it isn't meant to cause an acceleration, because it's not in current physics. It's not a force. A force in current physics is a concept that's difficult to describe at best, but fundamentally it requires an interaction, a push or a pull. Del from Beyond the Imaginary Curve showed that a pull doesn't exist unless it's a magnet, in which case there's a little bit more to it, but there are no pull forces in nature. There is something that's happening here that requires us to talk about it. And this visualization demonstrates exactly what my point is. My point is that as I increased the density of the medium, it caused pressure to increase against the sides of the container and on the underside of the egg, because we know that the salt's more dense than the medium. It added more gradient, more density to the gradient, and that basically pushed up the gradient, and the egg moving up took the egg up with it. That's what happened. The egg moved because the pressure below it increased, and the pressure was caused by mass. I played a quick clip the other day from the Globebusters show.
Force could be the pressure as well, right? It could be there's all kinds of forces
could
that
be.
we're talking about. Yeah,
It could be. I don't know. That's the whole thing. But the
where I demonstrated that Eru understood it, because he said the force was pressure too, and I agree. Sit back and enjoy this and watch this a couple of times. You should see clearly that this guy is demonstrating exactly what happened with the egg. Notice what he claims is the cause, and notice what he claims is not the cause. He claims that changing the density of the egg means that it changes its relative position. He does not claim that there is gravity pulling or pushing. So listen carefully to what he says, and also what he doesn't say. He does not mention gravity, and he literally says the only cause was changing the mass of the sphere, not the gravity. Watch this a couple of times. If you're not sure about relative density, then you should be at the end of this. If you are sure about relative density, you don't even have to watch it. But this proves, without any complex maths, any complex notions of mass attracting mass that's not mass attracting mass anymore, any of that nonsense, it is just the changing of the mass of this circle or sphere in the middle. It is exactly what I did in my test. Enjoy.
Let's have a look at a related phenomenon, namely buoyancy. Can our simple kinetic model maybe explain why some objects who have a lower density than the surrounding medium do not fall down like everything else does?
All solid objects in air are more dense than the air, guys. That's where this downwards bias perception comes from. This fact perceived by the human relative to the human only.
But actually stay afloat or even rise in the medium. Here's another simulation with another empty sphere suspended in the middle of the gas volume.
And as we can see, it's a perfect exact match.
But this time the sphere can move freely. I assigned the sphere a mass such that its density matches the average density of the gas, which is why the sphere is suspended in the gas and neither falling nor rising. If you look closely, we can see that the sphere is indeed movable and is undergoing Brownian motion due to randomly being pushed by surrounding atoms. I can now reduce the sphere's mass by pressing a button, and in response, the sphere will rise towards the top of the container. Then I can press another button to increase the sphere's mass, and it will sink towards the bottom of the container. Neither of these behaviors are programmed into the simulation, which still only follows the three simple rules I explained in the beginning. The buoyancy of the sphere is a direct result of the density and pressure gradient in the gas, which in turn follows from the three rules. There are more atoms pushing against the sphere and pushing harder from the bottom than there are atoms pushing against it from the top. The result is a net force differential pointing upwards. If that force differential is exactly matched by the sphere's weight, the sphere stays stationary. If the sphere's weight exceeds the force differential, the sphere drops. And if the sphere's weight is less than the force differential, the sphere rises. That was all. Thank you very much for watching and see you next time.
Oh, that was beautiful. So he demonstrated just by changing the mass of the sphere, it caused an acceleration, right? But remember, current physics states that mass is not an acceleration. Mass does not have a vector or a magnitude. It is simply a scalar. So just by changing something that has no vector, no direction, no magnitude, an acceleration occurred. And he literally explained why. It is a change in the net force differential caused by pressure. So just by changing the mass, he caused something to accelerate or to move, right? Mass isn't meant to do that. Bob from Globebusters, your position is untenable. You are not pushing science, you're pushing pseudoscience. There is no downwards direction, there is no bias. The perception of the bias is created by the density of the mass in question relative to the medium, and your perception is false because you don't understand that all solids are more dense than the medium. If you're a blurther, you think that this is all nonsense, right? Yet you ignore the demonstration, you ignore the definitions within scientific method, you ignore that gravity didn't do anything because if it can't by definition, yet you insist that it could. The blurthers are more dumb than Bob. But Bob, there is no downwards acceleration bias. And if there was, it doesn't accelerate matter. What does accelerate matter is relative density, and if something's in disequilibrium, pressure moves it, and that's what I demonstrated. Stop pushing pseudoscience, Bob, you're causing damage.
From Penn State University, there should be three types of variables in every experiment: the dependent, independent, and the controlled. The independent variable is what is varied during the experiment. It is what the investigator thinks will affect the dependent variable.
Here's a fun question for Riley. What's denser, an egg or water? If all that matters is relative density, then the egg should sink.